Now, well done, my brothers and sisters. Welcome to Science Vision Africa, aka African School of Grassroots Science, where we try to explain you science the way you understand it, and anybody can understand it. So today we go talk more about Newton's laws. Newton's laws. These actually laws of motion. That's how it's supposed to be. But they usually just call it Newton's laws. But it's just law of motion that we're talking about. Laws of motion. That's what we're talking about. Because it's law of something. Law of motion. But before I begin, let me state again, as I always say that I'm going to be teaching you the thing they teach you in school and the thing they don't teach you in school also. These laws, no be saying Newton law. I have said something like that before. These are laws of nature. Newton's law of motion. Or you can just say laws of nature. We are not, when we talk about these laws, we are not talking about laws that happen in Japan or America or Australia or London. We are talking about laws that happen everywhere, the same way, in Nigeria, in Kenya, in Ghana. These laws happen the same way. They are the laws of nature. They are not the laws of white man. I can as well write it as Obasanjo's laws. I can as well write it like that. And when I teach it, you understand it the same way. When I teach it the same way as Obasanjo's law, you will understand it the same way as you understand the Newton law. So it's just that Newton put these laws in writing. These are actually, as I like to call it like Newton's observations, which he noted. Yes, he deserves credit for it. But what I'm saying here is, these laws are not foreign laws. Unfortunately, due to brainwashed colonial education we inherited from Britain and France, teachers keep teaching this as if we are talking about foreign laws. And I feel peace when I actually realize now that I have to pass through that kind of education. So really, what Kwame Nkrumah was saying, that what happens in Africa is educational fraud. Any education that's not based on your history and your needs and heritage, the comments I think I will post it later, is an educational fraud. So at the end of the day, we can't have scientists because we are thinking of study of nature is foreign things when it's actually study of something around you. So that's by the way. Let me clean this up as I just in order not to sound strange. But as I said, this is my show, so I'm here to open up your mind, to think outside the box. So that's by the way. His first law, the first law, first, yeah. The first law, he called it the law of inertia. The law of inertia. nature. This law, this law talks objects where they for motion. Okay, alright, where I'll come to that. Alright, where the forest go continue to the forest unless something move on. Unless unless a force move on. Very simple. If you keep something on the table and lock your house and come out, maybe your phone. If you forget your phone in your house, on your table and leave your house, come out. The phone will continue to stay in your house. If you from that place even travel, you didn't come back, that phone will continue to stay there. Unless somebody, of course, open your house, shift the phone. Unless rats, they play, go shift time. Or something will make them to move before you move. Just imagine a football field. They enter to play football. The referee and everybody, players come to the pitch to start playing the ball. The ball is in the middle of the field. Suddenly they say the ball match has been cancelled and everybody go lock the stadium without removing that ball. What do you think will happen? The ball field is closed. The ball is there. The ball will continue to remain there unless either na wind blow am or a bird fly from sky, come perch on it, move it, or the stadium is opened back someday in the future to play another match. If nothing like that happen, the ball will remain there. So as you can see, this is a simple law of nature. We are not talking about foreign things. It's just a normal law. Normal law that already happened everywhere. Everybody knows it. Because of this, if you have a science mind, when they make such this kind of comments, you will have other ways of explaining it. You can deduce things from it. So because of this, he also deduce that because of this, it also means that objects where they move go continue to they move unless the force stop them. Something must stop it. If you throw something, up, the only reason that it don't keep flying off, going up because of the force of gravity. If there was no force of gravity, you throw it up, it will continue going up. That's what the law is saying. It's just that because of force of gravity, in this on Earth where we're there. Normally, the other places, other locations like the moon or other places that exist in the world, that as we talk from the beginning of what we saying, there are other places that exist that look like the world, just that people are not living there. So those places, some of them don't have no great force of gravity that we enjoy in this world. Those places, you throw something or you jump up, you will not be able to come down again. You have to find it difficult to come down. So that is it. So when you draw something, it's supposed to, it will continue going, unless something stops. Let me see whether I can make a small drawing about it. Really, it's not a big thing to understand. It's simple. It's a simple law that everybody already know. Let's say you have this thing. Let's say you have it and it's a cup. And you put it on a table like this. You put it on a table and forgot it there. Even a section of your room. This cup will continue to stay on that table. Unless something make them to move. It could be anything. Whether now you make them to move or something else, but if you didn't make it to move, it will continue to be there. So let's say there's another cup. Let's assume there is another cup. Another table made of, let me say this table is made of ice table. This table is made of ice, including the top. Everywhere is made of ice. This table. And you keep this cup. Okay, let me even say, let me redraw that. Let me redraw this table. Let's say this table will keep this our this table will keep this our cup of water slant like this. Let's assume the table slant like this and this cup is there. What do you think will happen? This cup sitting on ice table that is slant. So this table we could, let's assume this table didn't end. Just imagine with me. Just imagine that this table didn't end, but it's slat down, just keep going forever. And this cup is sitting on it. What do you think will happen? This cup will continue going down forever, for it to stop. There must be something that, whatever it is, no be a problem. But for it to stop, it must be something that will make it to stop. Either is if you I don't know how it's going to gather friction, from this ice table that's moving. This table cup will continue to move forever. That's it. That's a good explanation of what this law is saying in terms of moving things. Unless something make this table, unless somehow this table somehow at the end of it come get a unless this table at the end can't get something like something that block it from going, this table will keep on going. That's what this law is. So as you can see, it's just common law of nature that everybody knows. So what Newton did, that he started putting this as put keeping these records. Keeping this record, that's all I can say. But it's not a foreign law. It's the same law that happens everywhere in the world. What this law of inertia also mean is that an object with more mass will resist motion. In fact, this law of inertia is proportional with mass. So let me draw another curve. This law of inertia is directly proportional to mass. Let me say this curve with the water or without water in it, just an example. Let's say you weigh 5 kilograms. This is just an example. It could be anything. Let's say there's another cup of water. Let's say there's another cup or whatever it is weighing 10 kilograms. 10 kilograms. 5 kilograms, 10 kilograms. This one have more inertia because you have more mass. You have more of the thing that make up this cup or whatever is in it than this one. So not really necessary because of weight here. We're talking about the mass. The thing that make up this cup, whether it's plastic or whatever they use to do it. This one, in fact, this one is bigger than this one, or even if you have two similar cup made of this same thing, the one that is heavier in your hand is because it's made up of more of the other one that is lighter. That is why it is lighter in your hand. I think that's the way I can explain it. So this is related to this law of inertia that we're talking about. What it means that, in fact, if I told you now to bring me these two cups, naturally you would like to bring me this smaller one because it will be easier for you to do. So, example, I have a big bag. It will be a better example. Let me use it. Example, if I have a big bag like this, a very big bag, bag of popcorn, but this bag is made of popcorn, bag of popcorn. This bag is made of popcorn, a big bag. Then I have a bag here, a small bag here, and this a bag of cement. A bag of cement. You see now, it's not a matter of size. And I told you to bring me out of I just told you to go there and bring me out of them. Bring me the bag of popcorn that is very big in a large corner. And the bag of cement. Bring me anyone where you like. Of course, you are going to bring me the bag of popcorn because it will be easier for you to do. So, this bag of cement, because you have more mass, it's resisting movement. It have more inertia. You don't want this bag of cement do not want to move. This bag of popcorn is willing to move. So you have less inertia. You can even kick it. If you kick it, it could move. But this one, you can't kick it. It's not willing to move, like a mountain sitting in one place. Mountains have inertia, more inertia than anything. They are not ready to move. That's why I don't let me not go there now. You see some important, somewhere where they are telling you that you can make a mountain to move. Use that analogy because that's the biggest thing that could have an inertia. Because it's not willing to move. It's sitting in one place with heavy inertia. So really, that's what it is. The more inertia something have, the more mass it have. The less inertia something have, the less mass it have. The more willing you can move something. That means have less. Elephants have big inertia than a rat. The elephant is not willing to move. If I told you to pull it, pull the elephant, pull a rat, you will know it when you try it. So if even if it's moving, in the other side of it, that say object where they move will continue to move. Even if the elephant is moving and the rat is moving, all of the elephant and rat is running, but two of them have rope on their neck, long rope that you can catch. If you catch the elephant will carry you the run because it's resisting movement. It's resisting you. You want to keep going with that force. But the rat will quickly stop because you have less of movement. You have less power to resist movement because you have less inertia. But the elephant, which is resisting movement, will not allow you to stop it. It will keep moving. So really, that's what this law is saying. I hope you understand it. So I will explain the other remaining two laws in the next lessons. My contacts, science. Yeah. Okay. Also known as African School classes. Influence. School, Facebook, and school. That's it. Thank you for watching.